Hi everyone, this is Shivam. Welcome back to my channel. In my previous video, I mentioned that we'll be talking about nodes in the next video. But before understanding pods, nodes, or deployment, we first need to understand how Kubernetes itself is structured. Because once you understand Kubernetes architecture, everything else will start to make sense automatically. So in this video, we will clearly understand the Kubernetes architecture in a very simple and a beginner-friendly way. A Kubernetes cluster is mainly divided into two parts. One is the control plane node, which is also called master node, and another one is a worker node. The control plane is responsible for managing the cluster. The worker nodes are responsible for running your application. So let's understand both one by one. The control plane node is the brain of the Kubernetes cluster. It does not run any application. Instead, it decides what should run, where it should run, and how it should run. There are multiple processes which are running inside the control plane node. Now let's understand the main components inside the control plane node. The first one is API server. This API server acts as an entry point to the Kubernetes cluster. Whenever we run any commands like kubectl get pods, kubectl get service, these commands directly communicate with API server. Even dashboards, UI tools, and other services communicate with Kubernetes cluster via API server. So you can think of this API server as the front door of the Kubernetes cluster. Everything goes through this. Now the second process running under this master node is called controller manager. So this controller manager continuously watches the cluster. It keeps checking, is the required number of containers running on the node? Did any container crash? Did something needs to be restarted? If something goes wrong on the node, the controller manager takes action to bring the cluster back to the desired state. This is how Kubernetes provides self-healing capabilities. The third process running on the control plane node is called scheduler. This scheduler decides where your container should run. When a new container needs to be created, the scheduler looks at which node has enough CPU, which node has enough RAM, and which node is currently free. Based on that information, it chooses the best nodes and places the container there. So like we can see here, there are multiple nodes, and whenever a new pod which has to be scheduled, the scheduler will look at the different nodes and see which node has enough resources. In this case, we can see here that this node is only having one container. So if a new pod has to be scheduled, the scheduler will try to schedule the new container on this node. So we can say that the scheduler is basically the intelligent decision maker. The next process which is running on the Kubernetes cluster is called etcd. Etcd is the brain and memory of the Kubernetes cluster. It stores cluster configuration, node information, current status, and the desired state of the cluster. All the data are stored in key value format. If etcd goes down, Kubernetes loses its memory. That's why etcd is one of the most critical components of the control plane node. Now let's talk about the worker nodes. Worker nodes are the machine where your actual application runs. Each worker node has a process called kubelet, and kubelet is responsible for receiving instructions from the control plane node, creating containers on the worker node, and monitoring their health. Kubelet also reports the status of the container back to the control plane node. So what happens when a container crashes? Suppose this container crashed and this container is no longer available. So what will kubelet do in this case? Here the kubelet detects that the container stopped. Kubelet reports the status to the API server. The API server updates the etcd with the new cluster state. The controller manager notices that the current state does not match the desired state. So let's say on node 3, the desired state of the container was 3, and now only 2 containers are running. Now the controller manager requests the creation of a new container via API server. The scheduler, like we discussed earlier, selects the node, and once the node is selected, the scheduler asks kubelet to create another container, and this is how the container gets created. So the kubelet here acts as a bridge between control plane and the worker node. The number of containers running on a node depends on CPU available, RAM available, and the resource limit assigned. Because application runs only on worker node, the worker node usually have more CPU and more memory compared to the control plane node. It is important to note that if this control plane dies, you lose access to the cluster. That's why in real production environment, Kubernetes usually runs with multiple master nodes. This ensures high availability and prevents single point of failure. Kubernetes also uses something called a virtual network. This network allows control plane and worker nodes to talk to each other. It also allows containers to communicate across different nodes. You can think of this virtual network as something that turns multiple machines into one powerful system. A system where CPU and memory come from multiple nodes but work together. So this is the basic of Kubernetes architecture. In the next video, we will finally understand where containers actually run using pods and nodes. Once you understand that, Kubernetes will start feeling much simpler. So that's it for this video. I'll see you in the next one. Till then, keep learning.